All right, Algebra 2, we're going to go ahead and move on to Unit 5.5. I believe this is the last lesson for Unit 5. So we're going to look at roots, finding roots, zeros, solutions, x-intercepts. Again, they all mean the same thing. We factor and we solve. And then after that, we'll look at writing equations. All right, so this definition, if a number h is a root or a zero or a solution or an x-intercept to a polynomial, then x minus h, that binomial, would be a factor called a factor to the polynomial. All right, so if we know the solution for the zero, then we can turn it into a factor by changing the sign. If we know the factor, then we can find the zero by changing its sign or set the factor equal to zero and solve it. So this example, if we know that negative 8 is a zero or a root to a polynomial, then its factor is going to be x plus 8. Okay, so you can see it just changes signs. If positive 6 is a root or a zero to the polynomial, then x minus 6 is called the factor. All right, so let's go ahead and answer each of these questions given this polynomial x squared plus 3x minus 18. So we want to find the factor. So we have three terms, so we would use the x method. So negative 18 is on top, 3 is on the bottom. So our two numbers would be 6 and negative 3. Okay, so then the factors are x plus 6 and x minus 3. Use parentheses when we're writing our factors. All right, so listing out the factors to this problem, x plus 6, x minus 3. The order doesn't matter, again, as long as you list them out correctly. So you could put the x minus 3 first, and then x plus 6 second. The zeros, again, set the factors equal to 0 and solve it. They're just going to be the opposite signs of what the numbers are in the factors. All right, so from x plus 6, we get negative 6, and from x minus 3, we get positive 3. Those are the zeros or the solutions, and then roots, again, are just another name for zeros, and so it's going to be the same thing. All right, the degree of a polynomial, again, this is just review, is equal to the total number of solutions, zeros, roots, x-intercepts. They can be real or imaginary. All right, so example 1, if x minus 10 is a factor to this polynomial, find all the factors and zeros. All right, so now sometimes there's polynomials that don't factor, and so we have to use some other method to get the factors. So this x to the third minus 12x squared plus 12x plus 80, it's four terms, but this will not factor by grouping, it just doesn't factor. All right, so we have to use a different method to get the factors instead. And so they give you a factor to help you out, and so what they want you to use is synthetic division. All right, so you got to remember, use synthetic division. Now, since x minus 10, they're telling you that binomial is a factor, to use synthetic division, we have to change the sign. All right, so we're going to use positive 10 instead of negative 10. Okay, because 10 is the solution, and this is what you use in synthetic division. All right, and then our coefficients are 1, negative 12, positive 12, and 80. All right, and then we'll just go through the synthetic division, like all the other problems, multiply, bring it up, add down, keep doing that. Now, if you do this correctly, you should get a remainder 0. All right, and so I put a little smiley face. If you don't get a remainder 0, then you did the problem wrong. Okay, again, it's because they're telling us that x minus 10 is a factor, and because it's a factor, it divides evenly, and if it divides evenly, that means you get no remainder. Okay. All right, so now we're going to go ahead and write the new polynomial. And so the original problem was x to the third, so ours starts 1 degree less. And so 1x squared minus 2x minus 8. And now we have three terms here. And this three-term polynomial, we would use the x method to factor it. The negative 8's on top, negative 2's on the bottom. So the two numbers would be negative 4 and positive 2. And so the factors would be x minus 4 and x plus 2. All right, so now we want to go ahead and list out all the factors to this original polynomial, the x to the third minus 12x squared plus 12x plus 80. And so the factors are x minus 4, x plus 2, and then we have one more, and that's that x minus 10, because they're telling you x minus 10 is one of the factors, so you want to list it, x minus 10. All right, now we can get the zeros or solutions, set each factor equal to 0 and solve it. So from x minus 4, we're going to get positive 4. X plus 2, we get negative 2, and x minus 10, we get positive 10. And again, you just have to change the signs to get the zeros from the factors. All right, example 2, if 1 is a 0 to this polynomial, find all the factors and zeros. All right, so now they're giving us the 0 instead of the factor. So you want to see the difference. So if 1 is a 0, then we don't change the sign. We keep it positive 1. Right? Our coefficients are 4, -4, -9, and 9. Right? Again, just bring down the 4, multiply it, and then bring it up and add down. Just keep doing that. All right, so we got a remainder 0. Okay, that's great. Get the first step right. And now we want to go ahead and write the new polynomial. Again, the original one started with x to the third, so ours will start with x squared. So 4x squared. Now, the next term would be plus 0x, but because it's 0x, we're not going to put that in. And then minus 9. Okay. Now, 4x squared minus 9. It's two terms. There's no GCF we could factor out. So you have two methods to actually solve this. You could use factoring, difference of squares, or you could also set it equal to 0 and get the solutions, and then from the solutions you could get the factors. So, but this does factor, and so you want to recognize when things factor, okay, because we can square root these, and so we want to factor. All right, so the square root of 4x squared is 2x, and the square root of 9 is 3. Okay, remember it's going to be 2x plus 3, and then there's another one. Just change the sign, 2x minus 3. All right, so our factors to this problem are 2x plus 3, 2x minus 3, and then from that positive 1 is a 0, you're going to turn it into a factor, and so you just change the sign to x minus 1. Okay, so just remember, they give you the 0 and you need the factor, change the sign to put it into a binomial, and if you need the opposite, change the sign to get the 0. All right, so then our zeros, we're going to set each factor equal to 0 and solve it. So from 2x plus 3, if you set 2x plus 3 equal to 0, okay, you can kind of see what's going to happen. You know, if I go 2x plus 3 equals 0, I would subtract 3 and then divide by 2. All right, so I'm going to get negative 3 over 2. All right, so that's one of the zeros, negative 3 over 2. Then if I set 2x minus 3 equal to 0 and solve it, I would add 3 and then divide by 2. So that's going to be positive 3 over 2. And then from x minus 1, same thing, I would get positive 1. Okay, so those are the three zeros to this polynomial. All right, example 3. If negative 3 is a root to this polynomial, find all the roots. All right, so again, root is just another name for zeros or solutions. And since they're telling us that negative 3 is a solution to this problem, we're going to use synthetic division on this, and we don't change the sign. It's a negative 3. So our coefficients are going to be positive 1. Now, if you look at the polynomial, there's no x squared. It starts with x to the third, but it jumps to x to the first. So we have to put a 0 in for x squared. Then minus 13 minus 12. All right, so bring the 1 down, keep multiplying, add down. Okay, again, make sure you get a remainder 0 on these kind of problems. Then we can write the new polynomial. Okay, so this would be x squared minus 3x minus 4. Okay, then we can factor it using the x method. So two numbers that multiply to negative 4, but add to negative 3. Negative 4 and positive 1. All right, and so they want the roots or the zeros. And so from x minus 4, we're going to get positive 4. From x plus 1, we're going to get negative 1. And then the original one that they gave us, negative 3, that needs to be listed also. All right, so there's our 3 roots to this problem. All right, writing polynomial functions. All right, so given this graph, what we're going to do is write a polynomial function in both factored and standard form. We did this before, so this isn't going to be too new. And we can answer each of these questions. All right, so what are the zeros to this polynomial? So remember, zeros are x-intercepts, solutions. So wherever the graph crosses the x-axis, that's where your zeros are. All right, so we can see negative 3 is a 0 and positive 1. And according to this graph, if you count the slant, since they gave us the graph, we can see that this is a degree 2 polynomial. All right, and then we can go ahead and write this in factored form. You can use f of x for polynomial function. You could also use y equals if you want to write y equals. That's okay also. So given the zeros, we want to turn them into factors. So you just change the sign. So from -3, its factor is going to be x plus 3. Okay, so that's from the original, or from the very beginning of the notes. Okay, if h is a 0, then x minus h is a factor. Okay, and then +1 is a 0, so its factor is x minus 1. Right, so that is the polynomial function in factored form. All right, now we want to go ahead and turn this into standard form. So standard form just means multiply it out. All right, so we did this before again. So we're going to multiply x plus 3 times x minus 1 out. And so we have two binomials, so we're going to double distribute to multiply this out. So we're trying to get rid of the parentheses. So x times x is x squared. X times -1 is negative x. 3 times x is plus 3x. 3 times -1 is minus 3. Okay, now we can combine like terms. Again, we'll write this either as f of x or y equals x squared. Combining like terms, we have a plus 2x and then minus 3. All right, so there is standard form. You can see in both forms, in factored form and standard form, they're both degree 2. All right, now if they don't give us the graph, they will actually tell you what the zeros are. Okay, we're going to do the same thing. So 0 is a 0, -3, and +4. Since there's 3 zeros, this is going to be a degree 3 polynomial. Okay, number of zeros is equal to the degree of the polynomial. Now 0, its factor would be x minus 0. Now because it's x minus 0, what we want to do is go ahead and simplify that to just x. Okay, so try not to use x minus 0. It just makes it a little bit more complicated. When you start multiplying this stuff out, just write it as x. Okay, so our factored form, f of x equals x from the 0, x plus 3 from the -3, x minus 4 from the plus 4, or positive 4. All right, so there is factored form. Okay, you can see this is a degree 3 polynomial, 3 x's. All right, and now we want to turn this into standard form. So just like in a previous lesson, we would take 2 at a time and multiply them together. You can't multiply all 3 together. So I'll just take the first 2, x and x plus 3, and multiply those together first. All right, so I'm going to distribute the x in. So that's x squared plus 3x. Now I'm going to put that in parentheses, and I'm going to bring down that x minus 4. And I'm going to double distribute those two together. So I take the x squared, distribute that over. So that's x cubed. And then x squared times -4 is minus 4x squared. Then I'll distribute the 3x. So that's plus 3x squared. And then minus, is that 12x? Okay. X squared times x cubed, x squared times -4, -4x squared. And then 3x squared minus 12. Okay, so now that's right. So now we want to combine like terms. Okay, so again, I'll just write this as f of x equals x cubed is my highest exponent. I have 2 like terms in the middle, so it's minus x squared, and then minus 12x. Again, you can see that this is a degree 3 polynomial also because the highest exponent is 3. And we don't have any parentheses in standard form. All right, number 2, the zeros are 7, and it has a multiplicity of 2, and then another 0 at -5. All right, so its factor is x minus 7. Now, because it says a multiplicity 2, that means it occurs twice. And if it occurs twice, we're going to put an exponent 2 on there. Now, you could also write it as x minus 7 if you want to write it out 2 different ones, x minus 7, or just use the exponent 2. All right, and then from the -5, x plus 5. So there is factored form. So we can see that this is a degree 3 polynomial. Okay, if you count up all the x's, it's degree 3. And then we're going to go ahead and turn this to standard form. All right, so just like before, take 2 at a time. So x minus 7 squared, I would write that as twice, x minus 7, x minus 7. Okay, I'm going to multiply those two together first. I'll get that answer, and then I can bring down that x plus 5 and multiply that together. So I'll double distribute the x in. That's x squared minus 7x. And then minus 7x again, plus 49. Combining like terms. x squared minus 14x plus 49. Put that in parentheses. I'm going to bring that x plus 5 down now and multiply those two together. Okay, so here I take the x squared and I will distribute over first. X squared times x is x cubed. And then plus 5x squared. Okay, and I'll take the negative 14x and distribute that over. So that's minus 14x squared. Let's see, what is that? 14 times 5, I think that's 70. So that's negative 70x. Okay, and we'll take the 49. 49 times x is 49x plus 49 times 5, 245. All right, now we just have to combine like terms. All right, so again, you could write y equals or f of x equals. Our highest exponent looks like x to the third. We have two x squares we can combine. 5x squared minus 14x squared, that's minus 9x squared. And then there's two x's here. We can combine those together. It's negative 21x and then plus 245. All right, so there is standard form. All right, number 3, the zeros are negative 2i and positive 2i. All right, so there's only two zeros, so this is going to be a degree 2 polynomial. All right, so the factor for negative 2i is going to be x plus 2i. And then for positive 2i, its factor is x minus 2i. Okay, now we'll turn this into standard form. So we're going to take x plus 2i, x minus 2i, and we'll multiply those two together. So we're going to distribute. X times negative 2i is minus 2ix. Okay, and we'll distribute the 2i. 2i times x is plus 2ix. And then 2i times negative 2i is minus 4i squared. So remember, I times I is I squared. Okay, we're going to combine like terms. Now these two middle ones are going to cancel out. Okay. So those go away. So I have x squared. Now negative 4i squared, remember it's going to be plus 4 because I squared is negative 1, and negative 1 times negative 4 becomes plus 4. Okay, so plus 4. All right, and there's standard form. X squared plus 4. All right, and then number 4, our zeros are 1, negative root 3, and positive root 3. All right, so let's list out the factors. So x minus 1, x plus root 3, x minus root 3. All right, so there's our factored form. It's a degree 3 polynomial. All right, so anytime you're multiplying radicals, two radicals factors or two imaginary factors, always multiply the radical ones or the imaginary ones together first. So like on this problem, I wouldn't multiply x minus 1 and x plus root 3 just because they're next to each other. What I would do is multiply the x plus root 3 and the x minus root 3 together first, because if you multiply those together first, if you do it right, all your radicals will end up canceling out. They'll go away. Okay, and then that's easier to multiply to the x minus 1. Okay, so I'm going to take, because the order doesn't matter, I can take any two at a time. I'm going to take the last two and multiply those together first. Okay, so I want to multiply my radicals first. Again, we just double distribute. So that's x squared minus x root 3. So be careful, the x and the 3, when you multiply them, the 3 is under the radical, but the x is not. So you can't multiply x and 3 and make it root 3x. The x has to stay on the outside. Okay, then we'll do the same thing for the radical 3. We'll distribute that over. So radical 3 times x is plus x rad 3. And then radical 3 times negative radical 3 is minus radical 9. Okay, so make sure you put that negative on the outside. All right, now we can combine like terms. Now the middle terms are going to cancel out. All right, so we have x squared minus, now rad 9 is just positive 3, not radical 3, just 3. So you can see all the radicals went away, and that's what's going to happen when you multiply them together. Now we're going to bring that x minus 1 down. All right, and now we'll double distribute those two together. Okay, so I'll take the x squared first. So that's x cubed minus x squared. Okay, and then we'll distribute the negative 3. So minus 3x plus 3. And then I would try to combine like terms. There are no like terms. And so I have my standard form answer right there. X to the third minus x squared minus 3x plus 3. All right, and this last problem, this is more like a CASP type question. I just want you to kind of see how to answer it. Because you're going to be doing this on the computer, so you'd be just, clicking and stuff like that. Given the function f of x, this graph, answer each question below. So question A, graph a point on f of x where x equals 0. All right, so you got to understand the terminology for these questions. So given this graph, when is x equals 0? All right, so you're going to go to 0 on the x-axis, and if you draw a vertical line, you want to find the intersection point, okay? Because what we're trying to do is find a point on this graph when it's 0 comma something, okay? 0 comma something. So go to 0 on the x-axis and draw a vertical line, find the intersection point, and there it is right there at 0, negative 2. All right, so 0, negative 2 is where the graph uses 0 in the x-coordinate. Okay, so that's when x equals 0. So if you were doing this on the computer, it would tell you to click, a point on the graph somewhere when x equals 0. So that's where you'd put it. All right, B, graph a point on f of x where f of x equals 0. All right, so f of x, remember, is just another name for y. And so we want to know when is y equals 0. All right, so again, we're trying to find some number, comma, 0, some point that uses 0 in the y position. So here you're going to go to 0 on the y-axis and draw a horizontal line and find the intersection point. All right, and it could be more than one. And there's more than one on this one. So there's one right there, because that's the point negative 1, comma 0. So you can see 0's in the y position when y equals 0. And then there's another one right here, and that's at 2, comma 0. Okay, again, you can see that 0 is in the y position. So there's 2 points on this when f of x equals 0. And then this last question, if the line g of x equals 1 is graph a point on f of x where f of x is greater than 1. Okay, it's really wordy, so you kind of have to just break it down and what each one is asking. So the first thing is we want to go ahead and graph this line, g of x equals 1. Well, g of x, again, is just a function notation for y. So we want to go ahead and graph the line y equals 1. All right, so y equals 1 would be a horizontal line through 1 on the y-axis. Okay, so here it is right here. So that's y equals 1. So now we want to find a point on this f of x graph where f of x is greater than 1. So when is the y values bigger than 1? So that would be everything above that line. So you could take and put any point that's above that line, but on at the f of x graph. So, you could put one right here, and that would be fine. So you could put one here, put one here. It doesn't matter. As long as it's above that line, it answers this question. And you would just do one point. You wouldn't do multiple. I'm just showing you that it could be any place above that green line. Okay, and that's how you answer those questions.